welcome back to Riya Kankonkar's channel. Today we are going to learn a new topic from lesson number 1 of Mathematics 2, that is geometry. Let us now see what is the first topic. The first topic is basic proportionality theorem. The theorem will be helping us to solve practice set 1.2. Let's start learning. The theorem tells us if a line parallel to a side of a triangle intersects the remaining sides in the two. Let's start learning. The theorem tells us if a line parallel to a side of a triangle intersects the remaining sides in the two distinct points, then the line divides the sides in the same proportion. Before we go further, we will try to understand what does the theorem try to tell us. We will be highlighting two words in the theorem. Those are, first word will be if and the second word will be then. Why did we underline or why did we highlight these two words? Because they are the most important words for us to understand the theorem. The sentence written after if is to be written in the given information, and the sentence after then is to be written in the to prove information. So let us understand with the help of the diagram what does the theorem try to tell us. We will be breaking down these sentences so that we understand better. If a line parallel to a side of a triangle, line which is parallel to a side of a triangle, so this is triangle ABC, and line L is parallel to one of the sides, that is side BC of triangle ABC. Now let us move ahead. Intersects the remaining sides in the two distinct points. Which are the two sides with which the line L intersects? Let us see now. Side AB and side AC are the remaining sides, so the line L intersects the sides AB and AC. Two distinct points are P and Q. This is the given part. So what we will be writing in the given part? Line L is parallel to side BC and line L intersects side AB and AC at two distinct points P and Q respectively. Okay, so we are done with the given part. Let us move on to prove, that is the sentence given to us after then. After then, what is given to us is the line divides the sides in the same proportion. The line L, that is this line, divides the two sides AB and AC in same proportion. So when the line L will be dividing the sides AB and AC, how will it divide it? It will divide it in the ratio AP upon PB for side AB and AQ upon QC for side AC. It is telling us that the lines divide the sides in the same proportion. So we come to a conclusion that we need to prove AP upon PB equal to AQ upon QC. So we have now understood what is the given and the to prove part. Let us learn further. So the construction we have to do to find the proof is draw segment PC and segment BQ. Now let us see in the diagram. Segment PC is this and segment BQ is this. Always remember, whenever you do the construction in the diagram, we should always draw dotted lines and not normal lines like these. Okay, so we have understood now what is the construction to be done to help us to get the proof. Proof tells us that triangle APQ and triangle PQB have equal heights. Let us see in the diagram that where is triangle APQ and triangle PQB. So in the diagram, we see that triangle APQ is this triangle and triangle PQB is this triangle. In the proof, it says that triangle APQ and triangle PQB have equal heights. The height of triangle APQ is PQ and the height of triangle PQB is PQ again. That is why they tell us that triangle APQ and triangle PQB have equal heights, that is PQ. So according to the property we learned in the previous video, it tells us that area of triangle APQ upon area of triangle PQB will be equal to the bases AP and PB because the heights of both the triangles are equal. So let us see how to write it in the proof. Here in the proof we write it as triangle APQ and triangle PQB have equal heights. Therefore, area of triangle APQ upon area of triangle PQB is equal to AP upon PB. AP is the base for triangle APQ and PB is the base for triangle PQB, as we saw in the diagram. This is the first step. For this particular step, we give the reason as areas proportionate to bases. Because the heights are equal, the areas are proportionate to the bases. Now, let's see what is the second step. The second step here is we have taken another triangle instead of PQB. Now we have triangle APQ and triangle PQC. Let us see what do they tell us. Area of triangle APQ upon area of triangle PQC is equal to AQ upon QC. This is the second step. Areas proportionate to bases is the reason. That is, again in this triangle APQ and PQC, the heights are equal. Let us see in the diagram. So here in the diagram, this is triangle APQ and this is triangle PQC. So triangle APQ's height is PQ and triangle PQC's height is also PQ. So these two triangles have common heights and their bases are AQ and QC. That is why area of triangle APQ upon area of triangle PQC were proportionate to the bases. Therefore we write the areas of these two triangles are proportionate to their bases. Now let's move further. Segment PQ is common base of triangle PQB and triangle PQC. We saw that the base for triangle PQC was QC and for triangle, as we see in the diagram, PQ is the common base for triangle PQB and for triangle PQC, and segment PQ is parallel to side BC. Hence, PQB and PQC triangles have equal heights. Why do we say that? Because we learned in the previous video that the distances between the two parallel lines are always equal. So we know the distance between PQ and BC is equal because these two lines are parallel. That is why we say triangle PQB and triangle PQC have equal heights. Now let us move further. From this we conclude that the base of triangle PQB and triangle PQC is common and the height of triangle PQC and PQB is equal. So we will highlight it here that segment PQ is the common base and they have equal heights. What do we conclude from these two sentences? We conclude that as the base and the heights of triangle PQB and PQC are equal, the areas of both the triangles are equal. area of triangle PQB will be equal to area of triangle PQC. That is the third step. Now we are very near to prove the theorem. What does it tell us? It tells us that from 1 we learned that area of triangle APQ upon area of triangle PQB is equal to AP upon PB, and area of triangle APQ upon area of triangle PQC is equal to AQ upon QC from 2. And from 3, that is right in front of our eyes here, tells us that area of triangle PQB is equal to area of triangle PQC. Because these both are equal, the upper portion in the numerator also becomes equal. When we further do it, we get AP upon PB, that was equal to area of APQ upon area of PQB, and AQ upon QC, that was equal to area of APQ upon area of triangle PQC. Hence, we have proved the theorem that was given to us. Let us again go back to the theorem and see what we had to prove. Here we had to prove that the line divides the sides in the same ratio. That is, AP upon PB is equal to AQ upon QC, and we proved it in the last step. So we have completed with the basic proportionality theorem. Hope you have understood. It was very easy to understand, wasn't it? We will be learning the next theorem in the next video. Till then, bye.